Hello, my name is Tyler Ryan, and this is my Journal Club article presentation for long-term stability of surface EMG pattern classification for prosthetic control. So in this study, the goal was to evaluate the EMG viability for long-term prosthesis control. One of the main research questions was what happens to the classification of an EMG's data, and that classification accuracy, that's the accuracy with which it can classify what type of movement is intended as well as the force with which it's intended to be conducted. The accuracy of that classification during a controlled time of 5 days. The reason this is all significant, EMG is a common device used when considering operating controlled prosthesis. In the past, there have been unintended movements or maybe even unresponsiveness in prosthesis devices. So this experiment hopes to aid in understanding those limitations that an EMG has in controlling these prosthesis devices. There were only 5 total test subjects, all healthy individuals that were unbiased recruitments by the office conducting the experiment. 3 naive and 2 experienced. The experienced knew about EMG reliability as well as instruments used in the experiments ahead of time, whereas the naive were given a 15-minute introduction right before the experiment was conducted. Many of the references cited in the article explore much more in depth the failures of related areas to the experiment being conducted, whether that be prosthesis failures or electrode failures, or even in some cases EMG controlled prosthesis failures. One reference even conducted essentially the same experiment but with only 1 subject, so it gave the researchers some insight on what they needed to look out for in their experiment. The researchers began by evaluating the subject's maximum long-term voluntary contraction, and this just showed their maximum contraction over 20 seconds, so they'd use this as a basis for later data collection. They did that for 8 different classes of movement. There was wrist supination, pronation, flexion and extension, which you can see all of those on the left, hand opening, finger pinch, key grip, and note movement. Next, they formed trapezoidal profiles, which consist of a 1-second rise, a 3-second plateau, and a 1-second decline at 3 different force levels, 30%, 60%, and 90%, for their maximum long-term voluntary contraction. These trapezoidal profiles were made for the subjects to trace. The way that they did this, they sat them in front of a screen which displayed the feedback of how much force they were putting into the EMG sensors, and then they would adjust accordingly. This data was then evaluated by a 5-fold cross-validation process and repeated around 15 times a day over 5 days. The study didn't specify any IRB approval. However, they did get approved by the local ethics committee, and participants did sign consent forms. In the research, the experimenters used a form of linear discriminant analysis, which is a form of variance analysis, specifically the ANOVA form, but also a form of regression analysis that can discern between different patterns, in our case, classes of movement, and discern if they were determined correctly or incorrectly by the sensor, which is the EMG sensor in these experiments. While this type of analysis was effective for our case, it could be beneficial to use a linear or a logistic regression as shown on the right in the graph. Logistic regressions can be used to specifically compare a class of movement and a time in days to cement or dispel certain misclassifications that were made in the linear discriminant analysis. But overall, in the linear discriminant analysis, the results were significant. The researchers came away from their experiment with 3 significant findings. The first was that naive and experienced subjects had no difference in their mean evolution of tracking errors. This meant, in their interpretation, that there was no significant difference between these 2 subjects, and that whether you knew about EMG reliability and instruments used before you watched the introduction video did not matter. Second, on average, classification accuracy dropped by 4.17% per day between training and test days. They interpreted this as classification accuracy does decrease over time. And then third, 10 out of 64 classification error ratios fell outside of a 5% misclassification range. And they interpreted those 10 out of 64 errors as significant enough to classify them as misclassifications. Lastly, they just went over some limitations of their study. Obviously, it's a small sample size, and they only have able-bodied subjects, so they weren't getting a full scope of the population. And then second, they had a limited time window and resources, which they emphasized would be highly beneficial to be expanded on later in another experiment. So finally, I just wanted to go over the significance of this experiment. The experiment implies that EMG devices in their current state can't be relied on for their classification accuracy over extended periods of time. And we saw this through the demonstration that they did in a small time frame that they had. The classification accuracy of the EMG devices did indeed decrease, but we don't necessarily know what the reasoning was for that. The good thing is the study could be easily replicated, and as the discussion suggests, even put to a much larger scale, which is what they would have done if they had more resources and time. Some of the questions that come out of the study: would a larger sample size affect the data? Would someone who is not able-bodied have different results? Could longer time experimenting even lead to an adjustment to the procedure? And these are just my works cited, so thank you. Bye.